What would you like to get out of this session? Okay. Anybody else has specific ideas what they would like to hear? Yeah, wait. The three of us have some history. We take care for the sparkling. No, seriously, anything you guys would really specifically say, I would be really interested in to hear from you guys about why high water benchmarking is still mattering these days? No? It's too obvious, right? Doesn't work. Okay, fair enough. Yes?
Oh boy. I'm somewhat new to Mongo, but my perception was that like mission critical workloads maybe you wouldn't find them being run on Mongo and Atlas, but clearly this is, I would assume, the most mission critical type of use case. So maybe you could just talk a little about, why it fits, why it worked in this case, and why it will become more ubiquitous.
That's a good question. I think we pick that one up first. Want to stick to that one? Happy to? Okay, fair enough. So we still have to wait 6 more minutes. That means I have to make small talk more to you guys. What can I do? Anybody, good jokes like, comes a skeleton to the doctor, says the doctor, a little bit late. It doesn't work, sorry. I tried this for 20 years. That somehow doesn't work, but one day it will. So the question was, what about mission criticality, MongoDB? Where are we today and that kind of stuff? That's actually a good question. Anybody, anything else? Se habla para español un poquito, Andrés, huh? Hola. Multiple languages are spoken here. That's nice. We speak both Bavarian and German. Come on in, guys. Come on in. Warm up. This is the Fireside chat about banking. Huh? The fireless Fireside chat for security reasons. This is maybe more pure. Simon, you're more than welcome. No, the Simon is behind you. That's that dude. That's a real Simon. Yeah. Yes? Oh, he wants to MC. Okay, come on, bring it on, man. Come on up. Yeah, no. I'm the host. Why do you so negative about yourself? We should talk about that. Of course we need you. We always do. No, that's his job. That's Charles. There's no way out. Yeah. Wanna be part of the panel?
What's that?
Wanna be part of the panel?
I have a panel tomorrow. I haven't.
Yeah. Okay.
Yeah, I'm good. I'll be around. Yeah, if you need me, let me know.
Okay. Fair enough.
Thank you.
Did you brought a lawyer?
Oh, what?
Oh, whenever I am on stage, I bring a lawyer.
Oh. Next time I will.
Okay. Fair enough. It's amazing how many people are coming. So I repeat the question from earlier. Anything you would like to have specifically from this session here? So we talked about MongoDB mission criticality, and I take the question serious with all my jokes. It's a good one. No? There's still some seats free, kind of. In opposite to Oprah, there will be no cars given out at the end of this session. That was another joke, so it's really not working today. And no more skeleton jokes, I got it. That's pretty much harsh these days. Oh, anybody here needs a payment system? Talk to Simon. Simon, that wasn't advertising. I don't charge you for it yet. It's nice to see some faces who are not working for me or with me. That's really appreciated. Should we start on time, or is it like like in university, 5 are in the room, 6 are leaving, the professor thinks if 1 comes back, I'm still alone? One of those moments? No?
I think for the stream, it might be good
Yeah.
to start on time.
Yeah. Okay, you guys have another 2 minutes to escape, otherwise life becomes very unhappy. Nobody leaves during this session. Remember, this is a fired up chat, something like that. Oh yeah, he's closing the door already. My MC lost me, left me, not lost me, left me. So good afternoon, everybody. Oh, that was good. My name is Boris Bialek. I'm the global head of industry solutions, which is like we're the verticals while the rest of the company is horizontal. Rest in peace. So with me today are 2 people who will introduce themselves in a second. We do this very interactive. I have beautiful prepared answers and questions, questions which they will be answering. But this is a smaller group, and we're absolutely open if you have questions to ask. So at this point, I would like to ask Tony to shortly introduce himself.
Sure. Hi, everybody. My name is Tony Coleman. I am CTO at a company called Temenos. Temenos are a banking software company. We have over 3,000 clients, financial institutions around the world. Marketing tell me that means that 1.2 billion people use our software for their banking needs. So almost certainly many of you here use our software, and you probably don't know.
And the second person is?
Hi, I'm Jörg Schmücker. I lead the financial services part of Industry Solutions. I joined MongoDB relatively recently, and before that I worked 16 years for a major Swiss bank in various roles ranging from IT through trading and risk management.
So we have 2 real experts sitting here, which is really, really great. And at that point, maybe one question which I got asked today 3 times, which is, at which point and why did you decide to go to a document system, Tony?
Okay.
That's
Not a loaded question.
You have time.
Much then.
No.
Sure.
No. And by the way, you guys can comment and counter-ask afterwards directly. This is interactive. That's what Fireside chats are about. Tony, go ahead.
Yeah. So there's kind of 3 different answers to that question, right? So the first one is around the newer workload. So as Mark was saying, as any organization, we have a healthy mix of existing workloads and new workloads. So new workloads, it was easy, right? So you have some use cases, you have some business goals you want to achieve. It's all new. You can look at your toolbox and say, right, what is it that we want to do? And where you've got something that you want to query optimize, so we follow a CQRS pattern, then it makes a lot of sense. You choose your document model, and it's fantastic. And that's a really easy decision. Then there's, for us at Temenos, we have, like a lot of organizations, ISVs, we have multiple products. Some of those actually have a document model under the covers, although in the late 90s we didn't call it a document model, we would call it a hierarchical data model or some such. And so that is a piece of work that currently exists as JSON or XML, but it's stored in a relational database. And there's some work that we're doing to look at where we go with that workload. And as you can imagine, the Mongo team are quite keen on that move. And then we have other workloads, which are more traditional relational, with the third normal form and all of that stuff that Mark was talking about, and stored procedures and all of that. And those conversations are a little more interesting about how we move them. So that one's a conversation for another day.
Okay, he skipped the last one. We let him go on that one? Oh, yeah, okay. So, Jörg, how was your move in that regards from your own route? You may probably need to tell people what you did, actually. Sorry.
Yeah, well, I mentioned quickly that I worked as a FX trader and FX structurer. And the business that we were in were exotic FX products. The innovation was literally in the morning, somebody came up with a crazy idea, in the evening you sold the product to a customer. And in order to do that and process these transactions, if you then have to change your relational database schema every time you create a new product, that is really not going to go very well. So what happened very early is that we started saying, actually, we only need about 13, 14, 15 fields for pretty much all the processing we have. And the rest we can stick in a club in an Oracle database. Really, that's what we did. And it catapulted us forwards by 20 years. It was unbelievably efficient because we could trade something, invent something in the morning, trade it in the afternoon, and book it at night. So that's how I got into the document model. And then when you look at now and what banks do that are in the space, they're pretty much all on document models because it became so painful when you have hundreds of different products to structure them in relational databases. And then over time, that was long in the business side, and over time it became apparent that very little of the payload that the operations that you actually do profit from a relational model and fit neatly into an Excel table, essentially. So we started to moving more and more into a document model and a product agnostic way of doing stuff. Then we looked at customer data. Well, that's easy. Let's put in a document model. And it was all XML originally, and then moved over to JSON more and more of the APIs became document-based, and it all moved away.
But that was an implementation, just your implementation for yourself. This is a big difference between you and Tony, right? You build it for one bank at one time. Tony thinks about 3,000 banks and 1.2 billion people. He doesn't want to screw up, right? So what's your thought process when you started it? You described the three passes, but how do you start that one from the risk versus reward? Because there was a lovely question from the audience about MongoDB, mission criticality. How does this play together?
Yeah, so as you kind of hinted at, and as one of my colleagues say, we have to be all things to all people as an ISV, so it's a bit of a different kettle of fish. And the answer really, and this is where I'm too lazy to put the slide together, so I just need you to imagine this for me. So just think of database company logos, right? Just think of all of them that you can think of, and put them up on a slide, okay, in your mind. And then think, okay, let's go through some of the requirements that you need in order to use that database in a mission critical system. And you start off by saying, okay, we want it to be cloud native, by which we mean it wants to be available as a managed service. So straight away a whole pile of them fall off, right? Next you say, and I want it to be cloud agnostic because I want to be able to run workloads on multiple clouds. So again, now you're going to have a whole pile of those other logos have fallen away. Certainly all of the cloud-specific hyperscaler databases fall off. Then you say, but because we're in a highly regulated industry, there are some geos where either there aren't public clouds or for data residency, sovereignty, localization rules, you can't have those databases in the cloud. So you also want the same database technology to be able to run on-premise. Right? So now think how many logos are left. Just with those three, you've not got a lot of logos left, right? Then you add on, coming back to the mission critical piece. So we enjoy what I term as exceptional non-functional requirements around security, availability, HADR, privacy, and so on and so forth. ACID transactions being a key piece that has only recently been introduced. So when you layer those on, again, you have more of those logos drop off. And then you get to two factors which may be slightly strange to come at because they're not those non-functional pieces, but it's more, it's a slightly softer aspect, which is the desire for it to be open source. So what we're seeing is more and more when you introduce a new technology into a bank, there is a massive rigor around the due diligence. And if something's open source, then it makes the whole process a lot easier. And then last but not least, and it was something that Mark was talking about on stage, is a really vibrant and active development community. So by the time you've taken all of those into consideration, and that slide I can be bothered to put together, you can see that there aren't many logos left there. So that's how we think about it.
One left. No, just kidding.
There's not many.
No, there's not many. But the not many part, I think, is important to talk about because obviously, yes, we believe we have a great product, and it is a great product, but what happens in 10 years? So nobody wants to be oracleized, right? or Bialek, is this a verb? No, okay. So there are options, everything is JSON-based, so but the underlying decision, what you do is basically for the document model. That's really the initial driver to put this word into your mouth, right? Less than Mongo.
Yeah, but slightly controversially, there are other use cases where relational databases still have a place, right? So there are, if you put relational database logos onto that slide that I couldn't be bothered to do, there are a few that meet a lot of those requirements.
Yeah.
So I know it's your conference, but it's not 100%.
No, that's a fair thing, so.
Boris and team, can I ask a question? They gave me the mic, so maybe I can ask a question, if that's okay.
Yeah, sure.
Yeah, sure.
Rob Graham, I'm with Gravity 9, product engineering. We're looking at it from a sort of a compliance and structural point of view. What about a performance point of view? So you mentioned CQRS, assume because there's a lot of read-write constraints. What about for market data within the FX space? Is that are the solutions suitable for operations in that environment, and how would you recommend activating that for real-world scenarios?
Do you want me to say that one, Boris?
I think both of you have to answer that one. And by the way, that question was not planted, but fits right down the alley of performance.
You're welcome.
Yeah, but so there are certain things which magically getting disclosed now. Go for it.
So we recently ran a high water benchmark test to prove out this piece exactly. So part of what we're doing in our application modernization journey is moving to a loosely coupled distributed event-driven architecture. So lots of commas there as well. Part of that involves taking some of those workloads and query optimizing and following a CQRS pattern so that you do get it. But to prove that out, there is a healthy debate about how granular you make those services and how much you break it up, because you can spend a lot of time on the network if you're not careful. So what we wanted to do was prove out not only that the newer distributed architecture scaled, but also that the response times were still appropriate. So what we did is we stood up an environment on AWS with a few databases, and we had, so it's 200 million accounts, 100 million customers, and the customers was in a party microservice with running on Mongo. And then we threw 100,000 transactions a second at it. So 25,000 insert update transactions coming through, and then over an event stream being ingested into a holdings microservice for balances and transactions, running over Mongo again, and then querying over that database. So what we saw, so that was using Atlas, and so it was VPC peered to our main AWS account, and the response time we were getting out of Atlas was 1 millisecond.
How quickly before reads were reads stale? Like how long did it take for reads to no longer be stale?
Sorry, how long
did it take for the reads from the data source no longer be stale? Because with the CQRS system, there's
about 200 milliseconds.
Okay.
Yeah.
Yeah, the performance was pretty amazing. So the amazing part for me was knowing the old benchmark had 79 milliseconds before, and you suddenly hit 1. What is the first thing what you're doing? This cannot be right.
But yeah,
check the reality, but it was actually that fast.
But the question was more on the latency from the command system down to the query system, right? Yeah, it was about 200 milliseconds.
But from the database side, sorry, I need to do my marketing pitch. So 79 milliseconds down to 1 millisecond. But I would ask the same question actually to Jörg about your solution. How did you end up with performance behaviors?
So for me, when we looked at FX transactions, and you mentioned this as well, you were interested in market data as well, right? So market data is a different pattern than the CQRS pattern because you're ingesting tick data. Sorry for standing up, but otherwise I can't see
you.
You
don't need
right?
to sit the whole time. I'm standing here like a monkey.
So when you look at, and traditionally I would not have said that is a good fit for a document database, but I don't know if you've looked at the time series capabilities, that MongoDB has released over the last couple of, iterations. And they basically turn the model around and say with the bucketing, you actually have a whole time series in one point. So from the performance criteria compared to what you have with normal things, there's no difference to a normal time series database anymore. I think for the extreme low latency, high frequency trading cases, you don't want to use a physical database anyway. You do that in a streaming processor, co-located. That is C++ hardcode code. I don't think anybody does that. A friend of mine is the head of e-trading for Credit Suisse. They're thinking about using MongoDB, actually using MongoDB to store all the market data, which they then use to train the models. So for all practical purposes, performance isn't a problem, because also we have the compression.
So what we did in the benchmark is we had separate microservices for market and reference data, and actually we just pushed all that into a distributed cache. It's Redis under the covers. And so that's how we solved that problem.
Cool. Any other questions? You're not. You're grounded for one round.
I have a loud voice. You mentioned how is it?
No, that's
Okay. Oh, the stream. Sorry. Thanks. So this is like maybe a little bit of an ignorant question. Let's rewind the clock to whatever year you were mentioning using, I think it was like an Oracle, some SQL database for document store, which is like
This was me.
think a little ahead of time, which I like. So one of the comments mentioned was open source is good. We can like do our due diligence. Can you just explain that? It seems in my mind that seems like a little bit contradictory or like how does that work? If you can just share elaborate on that.
Yeah, so what we found is, and it's personal experience as much as anything, right? But when you want to introduce a new technology into any organization of any size, there's typically some sort of due diligence process around it. And it can be around vendor management, and it can be around open source in general, right? So if you just want to put, most organizations, certainly we have a robust open source policy so that the developer just can't find something cool on GitHub and pull it in. As a vendor, when you're pitching, to be fair, it's more on-premise than for cloud, but when you're pitching a technology stack to a bank, then it needs to align with their accepted technologies. And if you're pitching something that isn't on that list, then you have more hoops to jump through. And one of the things that can help, and it's not for every organization, right? So it's not 100% true, but we found that if you've got open source technology, then depending on the organization, that is usually seen as a benefit.
And I can bring up the same argument so with my job before, so you guys can LinkedIn me, then you're figuring out who that was. We dealt with several hundred banks, and I introduced MongoDB in 2016. So at that point, you went to a bank, Mongo, who? And they look at you really from the wide eyes. So one of the biggest arguments was indeed, as well for that case, it's an open source technology. So then the people already calmed down. If I would have said, well, that's a new database product. It's like whatever, SQL Server, Oracle, and you have to bring up a new database in the bank. No way. The end. And when you're an ISV specifically or produce for more than one implementation, and when you think you have more end clients in a broader community, then you try to reduce actually exactly these what question to Azure. And when you do that one, open source still helps. And this is a big, big argument for a lot of organizations. The other part is, let's be very blunt, MongoDB is available in a community edition as open source, as you heard this morning, 150 million downloads. So I think the last one, what I saw this morning, 15 million last month alone, ridiculous numbers, use our product as open source. So that drives as well other decision points about, Tony mentioned the community, and this sounds not marketing now, but when you think about where do I get developers from? One of the biggest discussions I have right now with mainframe dudes is, my developers are dying. And the first thing I was thinking, oh my God, COVID. But then I realized, no, the dudes are actually in the 80s. Congratulations. So I try to make it sound funny. I've one client, very, very nice session in Scandinavia done, in a very remote location. They don't get any mainframe people relocating. They had people who retired 3 times and they got them back out of retirement for freaking amounts of money, just that their system doesn't go down. And I'm not talking about a third grade institute. You will be surprised when you hear the name, which I will not bring up. So when you think about those kind of problems, this is quite complex. And then open source helps. So one argument of that client was as well, I know I get MongoDB skills here in the village. I said, oh my God, they're even here. So, but that sounds a little bit funny,
Yeah.
but I mean skills is an important part, right, around that one as well.
For sure. I mean, it's also kind of your ultimate exit strategy, right? So if you look at some of the guidance coming out of the EBA and EBC, so European Banking Authority and Commission, a lot of it, more specifically for cloud, but they want the banks to have an exit strategy, and it's specifically around data. So if you have all of your data in Aurora, say, and you need to get out of AWS, then you've got to get it out of Aurora. Okay, it's Postgres compliant or whatever, but you now need to run it. Whereas on an open source system, you literally can run it yourself if you need to.
Yeah, so was a good question, actually. Any other questions along the same line? Yes, there's a gentleman in the back. You like this format like this is better than me just asking the usual questions, do you love MongoDB? The answer is yes.
Yeah, it's great for you, Boris.
I try my best.
Yeah, hey, I was curious about the networking posture that you were talking about with doing a peer connection. Was that satisfactory for, security reasons, or is that what you use today?
Yeah, so you don't have to. We did it because the volume and throughput we were looking at was so high. I mean, we don't have clients that come near that. I mean, I was asked about the numbers on a different chat. So we have clients that regularly peak at about 10,000 TPS. So when I do a benchmark, if I do it at 100,000, then I don't have to keep running 10,000 TPS benchmarks because it's so high. So the VPC peering was good from a performance point of view. Yeah, I mean, there's an element of solution architecture you need to apply to all of this, right? It was a production grade environment, but all of the things that we talked about, TLS and all the rest of it still take place for sure.
And adding on to that one maybe a little bit, it's quite common by now to have the bring your own key, connect, private link, specifically when you have discussions over regulated industries. So the buzzword is PII, PCI, personal information, and the PCI card standards around that one. So when you look into those kind of things, it becomes automatically the encryption. That's as well where the discussion from Mark's keynote, to be a little bit here marketing now, comes in with the FLE2 part, that you have really these improved encryption capabilities end-to-end from that line over the private link from your application environment. That's a huge value add. And at that point, MongoDB becomes actually a data vault for you, literally. And that has a lot of examples and benefits for the implementation. But, I mean, Jörg, you implemented really on premises as well, right? Secure environments. So yeah. How did this one go?
So for us, we did separate out the client data from our transaction data, which meant that the security for the client, the private banking side, wasn't a big issue. Because that's where you have all the banking secrecy and all the other stuff where, the maximum fine in Switzerland is like, I think, 1 year revenue, which would kill a bank, right? It's just unbelievably punitive. You can go to prison for that. It's not fun. So we split that out because it was just too complicated. And then we could use with much more standard. To be clear, right, we introduced MongoDB, I don't know, 8 years ago or something, to offload some of our workloads that we had long before there was ACID. It wasn't our system of record. We used it as a very, very powerful storage mechanism to be able to reproduce the world or keep the world static while we did massive batch runs on the RISC. So it is kind of like a temporal storage layer for us, on top of what we had in relational databases, and the relational databases were not bitemporal, so you couldn't reproduce, and it wasn't performant enough, so we had that model. So that was a slightly different angle than Tony's, where really it's payments, you have client data all over the place. That's much harder than it was for us.
And little self-marketing, if you look up Temenos, MongoDB, Boris, you can choose the order. Then there's a blog actually where we wrote some more details, and there's a rather, how much is it, 48 pages or something document available, which talks about the art of possible on the banking side. So you may want to check that one out. If you don't find it, just drop me an email or PM somewhere, and I'm happy to get that to you. But the blog is pretty good around that one as well, which is now one angle which I would like to haunt Tony again with. Environmental ESG factors to the whole benchmarking. This is something which is close to all our hearts, because, I mean, we are the dirtiest ones of the world, right? We are the data people. We generate a lot of heat, a lot of energy. Tony, what was your experience? I know the answer, it's a little bit unfair, but still.
Yeah, so one of the really nice things that we found, related, really it's about efficiency as much as the sustainability piece, is that throwing 75,000 queries a second at this particular Mongo instance and about 20,000 updates on that. It was only running on, I think it's called an M80, which is a 32-core machine. So compared to what we would need to do if we'd stored that in, say, Oracle to get the same sort of query performance, I mean, I dread to think how many cores you'd need, let alone the disks, to service that up. So the footprint was, certainly compared to, and it is an unfair comparison, so shame on you. When we ran a benchmark in 2015, so this is a while ago, so older chips, older disks, and it was on Oracle, we were getting about 10,000 queries a second, and that was on about 300 cores. Now, it's not a fair comparison, so you can do the maths around
benchmarking is always about statistics you can fake. I know now, MongoDB runs 10 times faster than Oracle. He just said it. I'm done.
But that was not on a CQRS system, so and this is kind of, it's a bit of a spoiler for the talking game tomorrow, but if you can choose your data model and you can optimize for a smaller query set, then you can get the thing to absolutely fly. So
that is an important part. So, which brings me a little bit when you talk about the data set, data modeling. So componentisation is obviously a big part of the story here, how you build the data modeling. So what's the experience on that one? Jörg, maybe you start after Tony gets a breather.
So I described where I started my journey onto the document model and the document tribe, let's call it that. What I learned over the time is that when you have a document model, you actually don't worry about how you store stuff anymore, at least not as the first thing. When you think about a relational model, you think, oh, how do I get this into a relational model? When you think about a document model, yes, you think about how am I going to, ideally, you think about how I'm going to use the data afterwards. Because storing is very, very fast with a document. It's not a big deal. It's one I/O, right? You go over the network once, then you're done. Retrieving is quick if you do it with the right indices, right? That's quick, so very good at that as well. Not too many round trips here. So really you have to start thinking about how you want to do this stuff. And then suddenly you get into the space when you start thinking about usage models that you start to look about the domains, and we all have heard about domain-driven design and all these other things, and normally you say, yeah, but how do I find a domain? And for us, the transformation, me and my team, the transformation there was you start realizing that not everything is connected for many, many use cases. You find out that a customer's account number is not what you need with every customer interaction. You don't need, as I said earlier, we split out our client data because we didn't need it for most of when you do risk calculations, you don't need to know the exact name of the client and definitely not his address and phone number. So you can split that out, and then suddenly your domains can start to be split by what's my usage pattern. And that's not something you do when you have a relational database where you're constantly fighting with, getting the stuff in there, right? So the database we had, the legacy database we had for FX, and it only could handle FX, simple products. I'm not going to go into too much. It ended up having 588 tables, right? And all the exotics were in the document model as I described. So you can imagine how that allows you to freeze you up in your modeling and say how you do stuff. There's a whole thing when you start thinking about this, and the more you learn about how to use a document model, it changes the way you interact with your data. Stuff that is really hard relational becomes suddenly, oh yeah, that's how I do it. Oh, that's easy. Oh, great. Bitemporal storage on these things becomes really easy. You just store all the versions in one document. If you don't have thousands of them, that's perfectly fine. Don't have to worry about it. So I think it was quite interesting to see how much I learned over time, and me and the team learned about how to model stuff.
I think for us, it became a conversation about the healthy debate about bounded context versus replication of data, right? And especially in a distributed system where you've componentized everything, it's very tempting to kind of go on a purist bounded context route, but then you end up with a proliferation of data, and especially in banking around PFI and PII, so personal financial information and identifier information. And that's something that we wanted to be really careful about, regardless of the underlying data model or technology. So that bounded context debate versus a data composition and pulling it in at the perimeter is one to, yeah, you need to take a stance from a sort of design authority point of view.
Yeah, so this was very interesting to hear, you talk about bitemporality and other things with modeling. So as a longtime modeler, I'm curious, relational modeler, I'm curious as to, are there any good books or recommendations for folks that kind of want to learn the new world of document modeling?
Oh, that is harsh. So the best answer for that one is actually we have a course on the MongoDB University for that one. Yeah. And this is now not, again, product placement. This is a really cool class about, it's called data modeling. I think it's course 320 or something like that, if I have this correctly in my mind right now. The advantage from that one is it comes really from the practical side and goes through what is the best path to model. The other class, which I strongly suggest to everybody who's coming from RDBMS, is the M100. That's the SQL to MongoDB to the document model class. One bottle of wine, one evening, you're done, and you're really dangerous enough to be reckoned with. So here's my own journey to the whole subject. We did a project at my old employer, 28 products, let's bring together. There was the C#.NET fraction, one side of the building. On the other side was the Java Oracle fraction, hating each other. We needed to bring these products from different heritages together, which was a very painful exercise. What were the two problems to start with? Entity framework versus Hibernate. Everybody says, oh yeah, I understand that you want to do the other side, but my one is better. Just trust me. So this went up for several weeks, and then we came up with the idea, we moved the JSON route, which was very innovative at that time. And what do? 6 engineers into one room, architects, let's plan some bounded context is, modeling. Everybody was completely going crazy, nothing worked. People were literally attacking themselves for lunch. So then comes the developer in Rob, and Rob says, I'm done. What did Rob do? 2 lines of code in MongoDB. What were the 2 lines of code? Connect to database, persist object, rest in peace. That was all. He came out with a picture, and I use this today in slides still, which was exactly the object like it was for him. This dude was a developer. He was not a database dude. And by just doing these 2 calls, so much stuff was suddenly out in the open. This is our structure. And then we suddenly saw absolute stupid decision we have done before to, when you do relational things and build objects, sometimes very awkward moments can occur in a memory model afterwards. Nobody have ever seen that, right? Right. And we had suddenly this beautiful picture. Then we did 3, 4 iterations over several weeks. In the data, in the relational world, this would have been impossible. Impossible to say, yeah, we do multiple iterations in several weeks. We look at it like years, eons. And yeah, it was 4,000 tables before, 2,000 views, congratulations. How many collections, what do you think? 1. That was the outcome. The effort was really in the brain of the users, because we could not get our head around the base fact that you simply persist an object. That was so against anything we believed. And I was fighting it for literally days mentally before I accepted that actually works. And then we cut out 500,000 lines of code and throw it away because a whole data abstraction layer, beautiful designed over 15 years, was waste.
Yeah, don't.
That is literally the experience.
Don't only have one collection, kids. That's not the way to do it.
Well, for this example, it worked. We're talking about asset liquidity management platform, so I skip all the different instrument types and sub-objects and so on. It was quite funny. But we talked about component. Oh, sorry.
Question there.
Yeah.
Sorry, on data replication, I wanted to hear more about, we have like stringent never down requirements and stuff in this industry. Wanted to hear about how you shaped your disaster recovery, RTO, RPO requirements, all that kind of stuff.
So the short answer is we didn't. We are in the lucky situation, where those requirements are given to us either by the regulator or by the bank. And typically, on the SaaS business, I think it's 5 nines and 5 seconds for both RPO, and I think it's 5 seconds for RTO. It might be 5 minutes, I'll have to check. And it's why the move to a distributed database is basically the only way through it. You need an active-active setup. Ideally, you want to go at least multi-region, depending on how much you want, in our situation, how much the client is willing to pay, or how much your business sponsor is willing to pay. Going active-active multi-cloud is definitely an option. It was something about, I would say about 3 years ago, we saw a lot of interest from the market around active-active across clouds. And that was largely driven by some concentration risk regulation that was being formed. That changed, as I kind of mentioned earlier, towards exit strategy. So that sort of desire went away. But we've seen a resurgence around it as well. And of course, if you are there, you do protect yourself. And we've seen it, it's unusual, but you can lose an entire region. And at that point, there's nothing that Boris and Mark are going to do for you because, the region is gone. So that's when, multi-region, multi-cloud is there. So yeah, it's one of the things I say is, especially in banking, especially for some of our more interesting clients, they have the worst possible nightmare NFRs you can imagine, and that's just Monday morning for us, unfortunately.
In many cases, we run actually 5-node environments. So a good example is a large French bank with 3 letters. I think that's still legally correct what I do right now. And the basic question is basically you need 5 nodes for one reason, 2 data center 1 or region 1, 2 nodes data center 2 or region 2, 1 node at an unknown location in the mountains. So that means you can lose a complete data center, you're still in majority, but the most important part is you can bring down a node in a data center, and the data center is still active and has no problems. And then like the typical, I call it the vacuum day, right? They bring out the node, vacuum it out, bring it back up again, or move a data center, all those kind of things. That's the 5-node environments. We have some clients now as well who talk about the new things, what we're doing, which is the cluster-to-cluster replication. This is getting very hot, where you say, okay, I have a cluster running in 3 regions, but now I want to go into a different continent, but independent of that cluster into a different configuration. That's what we're doing. You saw the quote from Amadeus on stage. So that is mission critical. Airline booking, one of the largest airline booking systems in the world. Yeah, you don't want to let that one go down. 2 years ago, you would have said, who cares? But today, again, it's kind of important. Nobody would be here otherwise. Yeah. So that is the criteria. If there's more interest on the high availability side, I think the key part is really in that part, the abstraction, what we achieved. Before, when you had an Oracle Exadata, you had the shelf. And if you ever look up, bye guys, I understand, it's hard listening to me, I love you too, bye, out. But when you take a look to, I find it amazing, I had an Oracle presentation where they compared MongoDB to Exadata and made the proof point that MongoDB is not as available. And I tried to figure out how they got there. And they simply said an Exadata is 100% uptime. And I was like, nah, that doesn't look right. Then you look up their maximum security, maximum availability architecture. There's a nice, beautiful document, PDF on the Oracle side, updated regularly. And to achieve the same levels, they suggest you need 5 exadatas to replace a MongoDB cluster. No, this is not funny. This is, I know you're laughing, but this is not funny. That's a reality. What you need full redundancy, because they do a 5-node setup. Duh! They have the same promises, the same physicalities as we do at the end. And you need 5 nodes to achieve exactly that configuration in 3 different locations. And then try to do a driver update. Sorry, I shouldn't make my own jokes. Sorry, I apologize. Good, that was high availability. Sorry, I stop here right now. Otherwise, people get really sleepy. There's still some of you here, which is appreciated, by the way. So, any other questions? Otherwise, yeah? No? Nobody? Nobody's fighting me? No? Yeah? Simon?
Simon?
Thank you very much. I was listening to Snehal's presentation before about architecting for sustainability, and you mentioned before about ESG, etc. Do you think there will come a time where there will be pressure from maybe customers or investors which will cause maybe the RPO and RTO rules, let's say, expectations to drop away because the benefits of, we prefer sustainability over, a little bit of, outage. Do you think that will happen? Is that happening?
I think it's starting to happen. And one of the conversations I was having with the chap that runs our SaaS business office was around, I think AWS term it sustainably friendly SLAs. And essentially, it's a scale to 1, scale to 0 conversation, right? So, and it really comes down to all of us as consumers to say, actually, you know what? If it takes 2 seconds for my balance to come back, I'm okay with that because it meant there was a cold start somewhere, and maybe that's okay. And as consumers, that's something that we can drive, because at the moment, the discussion with the bank is typically, your SLA must always be 100 milliseconds regardless, and that means you are architecting to a scale to 1, not a scale to 0. So I think it definitely will happen, and I think it's starting to happen, and I think it's up to us as architects, engineers, consumers to drive that through the business, 100%.
I find it really funny when you say that, because when I look at what happens in the banking industry with all the risk models that we have to run now and real-time risk intraday, and the compute farms that do that kind of stuff, tens of thousands of computers, really running 24 hours a day, maximum power, to do what? Real-time risk, where to once in a blue moon have an event. So the question is, I wonder if that will happen, that somebody says, actually, do we really need real-time risk at that low latency quality, and can we turn some of those machines off? That, I think it's an interesting point. I never thought about it before. It's a very interesting question if the regulators will balance that. Because I think compared to the 30 nodes or 300 nodes, 10,000 computers, each with, 16 cores, just constantly running just for a risk model, that's just super wasteful.
I mean, it's just to take a slight detour, but on the same topic. So it's something that we've been tracking for a couple of years now, which is essentially the transactions per second per core. And we managed the last benchmark we ran, and this is not the Mongo workloads, so the other stuff, because we took out a pile of middleware which we just didn't need, and there was some good old-fashioned application changes, as well as some clever architecture changes. That was me, I'm going to claim that one. We managed to get that, the transactions per second per core compared to 3 years ago, and again, Moore's Law, etc. But it was between 3 and 4 times the improvement there. And it's something that we're working with AWS and Azure to track, because to use their terminology, that is the sustainability in the cloud. So we can make our stuff more efficient. the sustainability of the cloud is on them, and what we're tracking is what we're calling a sustainability index, which is their metric CO2 equivalent measures over our measures, and that will give us, in theory, something we can track that's cloud neutral. And that's something that our investors and our customers are very big on, and rightly so. It's something we're really pushing.
Just one quick comment to that exact topic. I think most often it may not be the technical solution that is the challenge. It's actually to, you say, translate what we do with the technology into the meaning for the business, the consequence for the business. And that's typically where we go wrong, right? So any good recommendations on how to address that? I guess you probably see a lot of different banks around the world.
Yeah. Find the most senior stakeholder, and that's the person you need to engage with, because that's the person that actually needs to make that call.
Cool. Yeah. Oh, there's more questions. So.
Hey, I have a question that relates to like these risk models and so on that are running. So like to take a parallel, at least in our company, when we do machine learning, we're focusing on like what I would say like matrix, like the final state before a model's built is using some sort of matrix. So either you're querying Mongo, then you're doing a lot of like ETL, ELT, whatever, some transformations. The model I see done more often is that like there's some extract process, some transformation, then it's loaded into like either like a data lake with like, you know, with some MapReduce or a columnar data store. Certainly that's like inevitable no matter where you're coming from. I guess like what's your like you're gonna, even if you're coming from a relational database, like you're still gonna have to deal with those processes. But I guess I'm curious, like how did you or how do you approach those sort of workflows? How do you approach that problem?
So when you look at the MongoDB Atlas platform, then over the last years, and you know, more and more, we have become not only a document, it's a multi-model database. So if you want to do your Spark, you go to your MongoDB database and get the data out in Spark. We do a little bit of magic under the hood so that that's possible. If you want to use, we learned today, if you want to use SQL, please feel free to use SQL. So that eliminates the need for you to worry about copying the data. It's the same thing with Atlas Search. We are copying the data under the hood for you over to Lucene, ultimately Lucene. So when you look at these workloads, you can isolate the workloads with analytical nodes so that you don't hit your operational store, so he can still run his 100,000 operations without your model killing his customers, or you know, going to a 5-minute payment cycle. So that is how we're addressing these things, and we're adding more and more of these multimodal capabilities to it. Obviously, when you go to search and you lose Lucene, then that changes the pattern they're using, but that's not relevant if you do search. So you stay, the core stays is the MongoDB database with its strong transactional guarantees, but then you can offload this stuff into the space that you want. So if you do machine learning, you're probably gonna be happy using the Spark connector, and then you can just get your data in the way your modeling framework wants it.
We're taking a slightly different route, which is essentially, so in our AI machine learning models, is actually going more towards a model as a service. So rather than have every customer with their own training data, is actually produce the model and sell the model as a service rather than the XAI as a service. So it's slightly, it's not solving your problem, but it's it's solving it by not having the problem, by saying actually what you want is the model. You don't really want the training data, you want the model, so we'll give you the model.
And then also you only need to calibrate the model once, train the model once, which is much more efficient. Yeah. But if you, yeah.
But I think there is a piece of work that we want to do, which is to look at what analytics we could be building in the Mongo database, the in-app analytics versus that more, you know, as Mark said, that longer term, slowly changing dimension stuff, which is, you know, not of Mongo's game. So there's probably a piece of work we need to do there.
I guess like as a follow-up question, do you see machine learning, let's just say in the future, interacting directly with like analytic nodes or analytic capabilities?
Let me rephrase this question, otherwise the people online will not hear it. The question was, can we do soon machine learning directly inside MongoDB? And the answer is you can do this already today. We have user-defined functions which you can run as part of the aggregation framework. And nothing prevents you from writing your own function, that one, and there's actually a pretty cool webinar done about that one. So it's called in-place machine learning and analytics or something like that. And that was exactly about that part. Is it perfect yet? To be very clear, no. Can you run simple models right inside of MongoDB through UDFs and segregation frameworks? Absolutely. And then one caveat already, like telco contract, 50 pages, is it machine learning in the meaning of industrial machine learning? That means inside of a payment process, inside of anti-money laundering, or is it more the advanced data science kind of functions where you don't have time-critical factors? So there are multiple factors coming in. That one I think I would table right now. This would be a little bit killing us here. I think there's one last question from the gentleman with the Confluent t-shirt.
Yeah.
Recognized.
And it's going to be topical, actually.
Okay, fair enough.
I heard you mention middleware retirement, and I was curious what inspired that and what kind of pattern you enabled with the replacement.
Okay, yeah. So this is good old-fashioned architecture stuff, right? So this is in a previous generation of the architecture, there were no app servers, there were no containers. This is 10, 15, maybe more years ago. And the way we distributed the load across multiple nodes was using a queue. So the workload would dump on a queue, and then you would have multiple consumers from the queue. And you know how these things happen. That's there. Then we moved to app servers, and that was fine. We just subscribed to the queues, message-driven beans, happy days. But we actually realized we didn't need them, because you can just consume directly over the network and let the network do the load balancing. And especially as you move to serverless and containers, specifically serverless, you really don't want to have this part of middleware you don't need. So we just got rid of the queues. And it was a great thing, because what we found historically is certainly a lot of our clients for the on-prem stuff, how can I put this diplomatically, weren't great at performance tuning the queues. Let's put it like that. So not only do we simplify the architecture and make it operationally simpler, we also saved between 20 and 200 milliseconds, depending on how they configured the queues. So.
Cool. Folks, I thank everybody for hanging in. How was the mood? I hope you guys had a good time. Thanks to Tony and Jörg.
Thanks for the questions, everybody. Yeah, great.